Now let us discuss electric potential due to a given distribution of charge. So there are two possible types of distribution. One is continuous charge distribution. One is discrete charge distribution. So if the potential at any point due to a group of point charges is nothing but algebraic sum of potentials due to each of the charges. So if there are basically, let's say 3 charges, that is Q1, that is Q2, and the last one is minus of Q3. These two are positive charges and these two are negative charges. I have to get the potential at this particular point A. Then I'll say potential at point A is nothing but potential due to our charge 1, which will be written as KQ1 by R1, and R1 is simply this distance. It is a scalar quantity and here it is positive because charge is positive. Same way, the potential due to point charge number 2. This distance is R2, then this is nothing but KQ2 by R2. And potential due to point 3 will be negative because this charge is negative, and let us say this distance is R3, then this is KQ3 by R3. But here it will be negative because charge was negative. So you can simply add them, add all the potentials with their proper sign. If you want to get the total potential, it is a scalar quantity. So there is no vector addition or subtraction. It just, you need to take care of the signs very properly. And if your charge distribution is continuous, then what to do? Then basically we assume an infinite small charge element, and that we call as dq, and it is this dq due to which we write the potential. So potential due to a small charge dq is k dq by r, and which is k is nothing but 1 upon 4 pi epsilon naught. So and then we integrate. So it is integration of all the small potentials due to those dq, and then we integrate such dq to get the electric potential due to a continuous charge distribution. Now let us do a question. So this question says that 2 point charges q and minus 2q are placed at a distance of 6a apart. Find the locus of the points in the plane of the charges where the field potential is 0. So in the plane of the charges, we need to get the locus of that particular points which are having 0 potential. So what I am doing is, I am going to take, so this is xy plane in which like there exists a charge q at the origin, and there exists another charge minus 2q at the 6a comma 0. So that is the separation between them is nothing but 6a. Now let us take a random point, that is x comma y. So at this point, we have to take the net potential at that particular point is 0. So how do we write the potential? I'll say potential due to q is nothing but kq by r. So k, what is q? Q is q by r. What is r? R is this distance. And this distance is nothing but root over x square plus y square. What about this potential due to this particular charge minus 2q? So potential due to minus 2q is k times q. Q is minus 2q by r square. What is the distance between this charge and this charge? I am using the distance formula. So it is root over x minus 6a square plus y square. And these two charges, this is a positive potential, this is a negative potential. We simply add them with proper sign and we say the total must be 0. So their magnitude must be always equal. So I am just equating their magnitude for V to be 0. So total potential to be 0, I will simply say that it is nothing but kq by root over x square plus y square is equal to 2kq by root over x minus 6a square plus y square. So this kq and kq gets cancelled. Let us square and then cross multiply. So we get x minus 6a square plus y square is equal to 4x square plus 4y square. And when we simplify this equation, so here we get 3x square plus 3y square minus 12a x minus, one second, this will be plus 12ax minus 36a square is equal to 0. And this equation is the equation of a circle. I am further simplifying it. It is x square plus y square plus 4ax minus 12a square is equal to 0. So as we all know that this is the equation of a circle, so we will say locus will be a circle. If we want to go further and want to get the center of the circle and the radius of the circle, so what will be the center of the circle? Center of the circle is going to be minus g minus f, right? So minus, what is g? G is 4a by 2, so that is simply 2a. And what about f? There is no y term, so then f is 0. So this is going to be the center of that circle. And what about the radius? Radius is nothing but root over f square plus g square minus c. So that is going to give me 4a square plus 0 plus minus c. So here is minus of minus 12 squared, so plus 12a square, and that will give me 16a squared, so 4a. So radius is going to be 4a. So the locus is going to be a circle in a plane. If we are going to talking about a plane, if we are looking in 3D, then like y and z axis are symmetric, so this will form a sphere with this center and this radius. So they are just asking in the plane of the two charges, so we can say it is locus will be a circle. In 3D it is going to be a sphere.